Hello, my name is Muhammad Daniel Hakim. Me and my team are from AKADEMI SAINS PENDANG. Today, we are going to teach you about chemical bond. What you will learn with us today are ionic bond, covalent bond, hydrogen bond, dative bond, and metallic bond.
Hi, I'm Ayosayhin. I'm going to talk about the ionic bond. The ionic bond is formed by the transfer of electrons between a metal atom and a non-metal atom. The formation of ions. Metal atom donates valence electrons to form a positively charged ion or cation. To achieve a stable electron arrangement, sodium atom needs to donate an electron. The process of donating an electron from the valence shell of a sodium atom is much easier compared to accepting 7 electrons from another atom. The valence shell is the outermost shell, as you can see in the model down below. After donating its valence electron, sodium ion achieves a stable octet electron arrangement. Sodium ion has 11 protons and 10 electrons. Thus, the charge for sodium ion is positive 1. Now, when a non-metal atom receives electrons from a metal atom to form a negatively charged ion. To achieve a stable electron arrangement, fluorine atom will accept an electron. The process of accepting 1 electron to the valence shell of fluorine atom is easier compared to donating its 7 valence electrons to another atom. After receiving 1 valence electron, fluoride ion achieves a stable octet electron arrangement. Fluoride ion has 9 protons and 10 electrons. So the charge of fluoride ion is negative 1. Now finally, formation of ionic compound. An ionic compound is formed when ions of opposite charges attract one another to form an ionic bond. How do ions of opposite charges attract one another? Well, when a sodium atom will donate 1 electron to achieve a stable octet electron arrangement, sodium ion will be formed. Fluorine atom will accept 1 electron from sodium atom to achieve a stable octet electron arrangement. Thus, fluoride ion is formed. So, sodium ion and fluoride ion of opposite charges will attract one another by strong electrostatic attraction force. Electrostatic attraction force are known as ionic bonds. A compound sodium fluoride NaF is formed.
Covalent bond. Covalent bonds are formed when no metal atoms share their electrons to achieve a stable duplet or octet electron arrangement. There are 3 types of covalent bonds: single bond, double bond, and triple bond. Single bond. A single bond is formed when 2 atoms share a pair of electrons. Chlorine atom, Cl, needs 1 electron to achieve a stable octet electron arrangement. 2 chlorine atoms, Cl, each contributes 1 electron to share a pair of electrons to form a single bond in a chlorine molecule, also known as Cl2. The formation of covalent bond can be visualized using the Lewis structure. Lewis structure only shows the valence electrons of the atoms involved. A pair of electrons shared is represented with a line between the 2 atoms. Double bond. A double bond is formed when 2 atoms share 2 pairs of electrons. Oxygen atom, O, needs 2 electrons to achieve a stable octet electron arrangement. 2 oxygen atoms, O, each contributes 2 electrons to share 2 pairs of electrons to form a double bond in an oxygen molecule, O2. Triple bond. A triple bond is formed when two atoms share three pairs of electrons. The nitrogen atom N needs 3 electrons to achieve a stable octet electrons arrangement. Two nitrogen atoms N each contributes 3 electrons to share 3 pairs of electrons to form a triple bond in nitrogen molecule N2.
Hydrogen bond. Hydrogen bonds are attraction force between a hydrogen atom H that has bonded with an atom of high electronegativity such as nitrogen and oxygen O or fluorine F with nitrogen and oxygen O or fluorine F in another molecules. For example, water molecule H2O can form hydrogen bonds among water molecule H20. These are the images that show. Oxygen atom O has high electronegativity. Attraction force between hydrogen atom H in water molecule with oxygen atom O from another water molecule forms a hydrogen bond. Water molecule H2O consists of 2 hydrogen atoms H and 1 oxygen atom O. Hydrogen H and oxygen O are bonded by sharing electrons with one another. This type of bond is a covalent bond. Role of hydrogen bonds in daily life. There are protein molecules that form hydrogen bonds among one another in a hair structure. Do you know why hair sticks together when wet? When hair is wet, protein molecules no longer form hydrogen bonds among themselves. Instead, protein molecules will form hydrogen bonds with water molecules H2O. Water molecules H2O will also form hydrogen bonds with other hair protein molecules. This causes hair to stick together. Have you ever come across the problem of turning the page of a book where the page sticks together? To overcome this problem, you lick your finger before turning the page. Why does a wet finger help to turn the page of a book? Cellulose in paper consists of hydrogen atom H that are bonded to oxygen atoms O. Water molecules H2O on the wet finger will form hydrogen bonds with the cellulose in paper. Because of that, paper will stick to the finger. Effect of hydrogen bonds on the physical properties of substance. Compounds in the form of liquids reach boiling point when the attraction force between molecules are overcome. In the covalent compound of ethanol C2H5OH, there are hydrogen bonds formed between molecules other than weak van der Waals attraction force. Strong hydrogen bonds are difficult to break. More heat energy is required to overcome the weak van der Waals attraction force. Besides breaking the hydrogen bonds, as a result, the boiling point of ethanol C2H5OH is high. On the other hand, molecules like chlorine, C, which do not form hydrogen bonds, have lower boiling point compared to ethanol. Ethanol, C2H5OH, is also soluble in water. The solubility of ethanol C2H5OH in water is due to the formation of hydrogen bonds between the ethanol molecule C2H5OH and water molecule H2O. Ethanol C2H5OH consists of hydrogen atoms H that form covalent bonds with oxygen atoms O. So the oxygen atom O in ethanol molecule C2H5OH can form a hydrogen bond with the hydrogen atom H from water molecule H2O. The hydrogen atom H in ethanol molecule C2H5OH can also form a hydrogen bond with the oxygen atom O from water molecule H2O.
Dative bond. Dative bond or coordinate bond is a type of covalent bond where the electron pair that it shares comes from one atom only. How does such sharing take place? 1. Oxygen atom O achieves octet electron arrangement and hydrogen atom H achieves a stable duplet electron arrangement in water molecule H2O. 2. Hydrogen ion H plus does not have any electron in its shell. 3. The lone pair of electrons that are not involved in covalent bond in water molecule H2O will be shared with hydrogen ion H plus through the formation of dative bond. In hydrosonium ion H3O plus, oxygen atom O and all hydrogen atoms H have achieved stable octet and duplet electron arrangement respectively.
Now, lastly, metallic bond. Metal atoms are arranged closely packed and orderly in the solid state. Valence electrons of metal atoms can be donated easily and delocalized, although in the solid state. Metal ions that are positively charged are formed when valence electrons are delocalized. All delocalized valence electrons can move freely between the metal structure and form a sea of electrons, as you can see in the diagram. Electrostatic attraction force between the sea of electrons and the positively charged metal ions form the metallic bond. Now, when electrons of metal atoms are delocalized in the sea of electrons, the metal can conduct electricity. Electrons that move freely in the metal structure carry the charges from the negative terminal to the positive terminal when electricity is supplied.
That's all from us. See you in the next video. Kindly like and subscribe.